This call is now being recorded.
Roll number 54.
Hello.
Can you hear me, beta?
Yes, sir. Yes, sir.
Okay. Please turn off your mic. We were discussing in our previous lecture line spectra. Okay. We have discussed line spectra. No. Okay. We have discussed parameters of signals. We said that we use frequency domain analysis because in time domain analysis, it is very difficult or it is impossible to analyze the frequency content of a signal. We can analyze amplitude, we can analyze power, energy, or the time period or periodicity in general, but we cannot, it is very difficult to analyze the frequency content of a signal. Okay. So this takes us to a different discussion. This takes us to a different discussion. So we'll be discussing line spectra. These are some of the fundamental terms which are used for frequency domain analysis or in general Fourier analysis of a signal. So these are the fundamental terms. We'll be first defining the terminology. Line spectra. Line spectra.
सर आप स्क्रीन शेयर नहीं कर रहे
Okay. I am not sharing. No problem. It is by mistake. I forgot to share. Okay. Is it visible now? It should be visible now.
Yes, sir.
So line spectra, we'll be discussing line spectra. Okay. Line spectra. So what is line spectra? Line spectra is basically the signal represented in the frequency domain. Frequency domain is called as line spectra. Okay. So any signal which is represented in frequency domain, it is known as line spectra. Okay. It is known as line spectra. Please remember that in time domain, we have our x-axis is time. Okay. Suppose this is the amplitude of the signal, or it is y of t. Y of t is the signal, and the x-axis is time. The x-axis is time. Whereas in frequency domain, you have x-axis as frequency. Okay. So how the signal will be represented in frequency domain? This is what is known as line spectra. Okay. Line spectra is just like a graph, as we show in time domain analysis, but it is shown in a different way. I'll show you how the frequency, how we'll represent the signals in frequency domain. So in frequency domain, representation, the variable plotted on the x-axis is the frequency. You have to remember this thing. So in frequency domain, the variable plotted on the x-axis is the frequency f rather than time. Okay. Rather than time t. So signal is not plotted against time, but it is plotted against frequency. Okay. It is plotted against frequency. Now see, the line spectra, it generally consists of two different graphs. Line spectra consists of two graphs. Okay, it consists of two graphs. The first one is known as amplitude spectra or amplitude spectrum. Amplitude spectrum, okay, which is nothing but amplitude, a graph of amplitude versus frequency. So this is nothing but a graph of amplitude of the signal versus frequency. Okay, what is the second part? Second part, it consists of two parts. तो लाइन स्पेक्ट्रा में जनरली दो पार्ट्स होते हैं. One is amplitude spectrum, another is phase spectrum. The second one is known as phase spectrum. Okay, what is phase spectrum? Phase spectrum is nothing but it is a graph of phase versus frequency. Graph of phase versus frequency. Okay, okay. So let us take an example now to show the amplitude spectrum and phase spectrum of a signal. Okay, now see, we have a signal. For example, we have a signal x of t. Okay, x of t, and its line spectrum is shown below. So one of them is say for example, this is your signal. This is in time domain. Okay, this is in time domain. So let us say this is my signal. This is a sinusoidal signal. Okay, what are its properties? One of the properties is that it has amplitude equal to a. So this signal is x of t. So one of the property is that it has amplitude equal to a. Another property is that its time period is equal to t naught. Fundamental time period is equal to t naught. Okay, that is another property. So this is time axis. So if the time period is t naught, what is the frequency? Frequency of the signal is equal to f naught, which is equal to 1 divided by t naught. Okay, frequency is always equal to reciprocal of time period of the signal. Okay, now see, if we convert this into line spectra, the line spectra will be shown like this. So we will have two different graphs. One is amplitude spectrum, another is phase spectrum. Its amplitude spectrum would be something like this. This is 0 here. Okay, now see, what is the axis that will be plotting here? It is frequency axis. Okay, so signal is plotted against the frequency axis. So first thing, in amplitude spectrum, first we'll be plotting amplitude spectrum. In amplitude spectrum, we plot amplitude versus frequency. What is the amplitude of the signal? It is A. Okay, amplitude is A. Amplitude of the signal is A. So where is so this is A. Okay, amplitude of the signal is A. So we'll mark it somewhere. Say for example, this is A. This is A. A is the amplitude. Okay. Now the second thing is on frequency, the frequency of this signal that is shown in the time domain, its frequency is f naught. We don't know where is f naught, but let us mark it somewhere here. Okay, so this is the component, single line. You have f equal to f naught, and the height of the line will mark its amplitude. Okay, this is amplitude spectrum of the signal. Amplitude spectrum of the signal. The second thing is phase spectrum. The second graph would be phase spectrum. So phase spectrum is similarly, we can mark it here. Say for example, we'll mark it here. So you have phase spectrum. It is phase versus frequency. So you have frequency here. So this is amplitude here. Amplitude. Okay, this is amplitude. So this is phase. Okay, phase. So at 0, this will be 0 frequency somewhere here. So this is 0 frequency, then frequency goes on increasing. Similarly, you have 0 phase somewhere here, 0 degree. Then your phase could be 180, or it could be 90, it could be less than 90, more than 90, it could be 270, whatever it is. If I say, for example, that the phase is 90 degree. Phase in this signal is 90 degree. Okay. If I assume that phase is 90 degree, do not be confused. You will say, how is the phase 90 degree? I'm just giving an example. Okay. I'll tell you why the phase is 90. So if I say the phase is 90, so somewhere at frequency equal to f naught, the phase is 90. So let us say 90 degrees somewhere here. Okay, this is 90 degree. This is 90 degree. So your phase is somewhere here. So you'll mark the phase like this. Okay. If I assume my phase shift or phase in the signal is zero, if I assume my phase is zero, so I'll draw two graphs. In real sense, we'll draw only one graph. So phase will be either 0 or 90 or whatever it will be only one finite phase. I'll tell you what will be the phase. But right now, I'm just assuming that if phase is, for example, this is also phase, okay? This is a phase spectrum diagram. So I have drawn two different phase spectrum diagrams. If phase is 90, then this one is true, okay? This one is true. So here, in this signal, phase phi is equal to 90 degree. But if phase phi is equal to 0 degree, okay, if it is 0, then it will be marked like this. It is 0, okay? So this is 0 degree. And where is it? It is at f equal to f naught. F equal to f naught, okay? F equal to f naught. Is that fine? I think I'll ask students. They will help me or tell me whether they are able to understand this thing or not. Roll number 5. Roll number 5, बेटा आपको ये समझ में आया? Roll number 5. Can you hear me? Please turn on your mic.
Yes, sir.
हाँ बेटा, कोई सवाल तो नहीं है?
No, sir.
Okay. Roll number 33. 33. We cannot hear you, बेटा. Please turn on your mic. आपको समझ में आया बेटा? Roll number 33 is not here.
हेलो
हाँ, आप क्यों नहीं बात कर रहे हो बेटा?
सर, मैंने सुना ही नहीं वो।
अच्छा, आप लेक्चर अटेंड नहीं कर रहे हो?
सर मैं कर रहा था लेकिन नीचे पापा ने बुलाया इसीलिए उनके पास था।
अच्छा ठीक है, आपको ये समझ में आया? फिर तो आपको पता नहीं होगा. Okay, what about roll number 4?
जी
Roll number 4. Roll number 4. Roll number 14. 14 is here.
Yes, sir.
आपको बेटा समझ में आई है?
जी, sir.
Most of the boy students, they log into the meeting and then they leave. It seems like that. Anyway, so this is how phase spectrum and line spectrum, this phase spectrum and amplitude spectrum of a signal is plotted. In general, amplitude spectrum plus phase spectrum together, they are known as line spectrum. Okay, they are known as line spectrum. In general, amplitude spectrum plus phase spectrum is known as line spectrum. So this is amplitude spectrum. This is phase spectrum. This is phase spectrum. Okay. Anyway. All right. Now, steps to plot the line spectrum. How do we plot line spectrum in general? Okay. So these are the steps to plot line spectrum. Line spectrum. Steps to plot line spectrum of a signal. What are the steps? Following are the steps. Okay, I'll write down in the form of points, then I'll explain them. Now see, independent variables which are plotted on x-axis, okay, plotted on the x-axis, that is frequency axis, okay. F is in hertz. Please remember that it is in hertz and not in terms of omega. So independent variable that is plotted in line spectra, you have to first consider that it is in hertz. It's in hertz, okay, and it is not in omega, okay. The second thing that you have to remember is that phase angle is always measured with respect to the cosine waves, okay, with respect to cosine waves. Hence, it is necessary to convert sine waves to cosine waves before you plot them, okay. Now see, line spectrum में phase spectrum जो होता है, it is always measured with respect to cosine waves. So you will always measure phase with respect to cosine waves, okay. Now see, the above wave that you have here, it was actually a sinusoidal wave, okay. And if you will measure cosine wave is something like this, okay. Cosine wave will be something like this, and you'll have same time period. Just a second, give me a second. Okay, so if you compare these two waves, one is sine wave at the top that we had to plot, whose line spectrum we had to plot. But since line spectrum is always plotted with respect to cosine wave, so with respect to cosine wave, what is the phase difference between sine wave and uh, cosine wave? It is 90 degree, okay. It is 90 degree. That is why I mentioned here that the phase spectrum will have 90 degree here, okay. That's why I mentioned the phase spectrum of 90 degree for sine wave, because sine wave or phase spectrum is always measured with respect to cosine waves, and if your wave or your signal is given, with you, it is in the form of sine wave, then it is important or it is necessary to convert that sine wave first into the cosine form. So for example, I have a sine wave, okay, that we used to have sine omega of t. Sine omega of t was the wave, or we have sine omega of t, which is y of t or x of t. Sorry, x of t is equal to sine omega of t. In terms of cosine, we can write it down cos of omega t minus 90 degree, okay? Cos of omega t minus 90. Now see, you have a phase shift here, it is minus 90, okay? Phase shift here minus 90. So I should have written here minus 90. Although this phase shift was to be drawn, it should have been, from the lower side. जो ये phase shift था, ये मुझे बनाना था असल में ऐसे, okay? From this side. So say for example, this is minus 90. That would have been more appropriate. ऊपर से पॉजिटिव फेज है, नीचे से -90 है. But whatever phase shift, whatever signal you have, first you have to understand and you have to remember that we need to convert it into cosine form. Then we have to plot its spectrum. Then we have to plot its spectrum. Okay. So here phi or phase difference, it is equal to -90. Okay. Sine theta, it is equal to cos theta minus 90. Sine theta is equal to cos theta minus 90. So this is how we convert every sine wave into the cosine form. The third point, you have to remember that the amplitude is always regarded as, or it is considered as positive. It is regarded as positive. Okay, it is regarded as positive quantity. So if suppose we have amplitude negative, okay, if we have a negative amplitude, suppose we have a signal whose amplitude is by nature negative, okay, inherently its amplitude is negative. So if you have a negative sign appears in your amplitude in the given signal, those negative signs, they should be absorbed in the phase change, to keep amplitude positive. Okay. So what I'm trying to say is, in amplitude spectrum, you cannot have a line like this. आपको नीचे से line नहीं आ सकती है. That is not possible. Amplitude will be always positive. You have to consider amplitude always positive. Okay. If by chance your signal is such a way, it is mentioned in such a way that its amplitude is inherently negative. Okay. Its amplitude is negative. Then that negative sign, it has to be absorbed in the phase. It has to be absorbed in the phase. What is the example for that? The example for that would be like this. Say, for example, your x of t is the signal, which is equal to -a times cos omega t. Okay, this is your signal. Now see, if you understand the signal, your amplitude is here negative. Your amplitude is here negative. But you can rewrite the signal in this form. You can write it, the signal could be written as a times cos of omega t plus minus 180. Okay, that is cos theta plus 180 degree. It is equal to minus cos theta, or cos theta minus 180 degree. It is also equal to minus cos theta. Now see, this minus sign you have to absorb in the phase. This minus sign you have to adjust it inside the phase. Okay, that is what I am saying, that if your amplitude is inherently regarded as positive, it is considered as positive. So if you have a negative, by chance, if you have a negative sign in your amplitude, they should be absorbed or adjusted in the phase change to keep the amplitude positive. So amplitude should be always positive. While plotting these graphs. Okay, I'll give you certain example now that will help you to understand this thing. Okay, so say for example, I have an example now here. So I have an example. The example is like this. Sketch the line spectrum of the following signal. Sketch the lines spectrum of the following signal. So I have a signal like this. Y of t, it is equal to 3 minus 5 times cos of 40 pi t minus 30 degree plus you have 4 times sine of 120 pi t. Okay, this is my signal. Now see, if you understand the signal, if you try to think over the signal, it has 3 parts. One part is this one, another part is this one, and the third part is somewhere here. Okay, third part is here. So this signal, it has three components. It is a composite signal. The signal that was there, this was a pure signal. It was a pure sinusoidal signal. Okay. ये सिग्नल जो थी ये प्योर साइनोसाइडल थी, इसमें एक ही सिग्नल था, इसमें एक ही कंपोनेंट था. तो अगर हम इसको लिखते इन द फॉर्म ऑफ mathematical form, so it would have been x of t is equal to a sin theta t or a sin omega t. Okay, तो इसमें एक ही component था. But the question that is given here, it has three signal components. Okay, three signal components. And first signal component is DC component. First signal component, DC component. Okay, so y of t, it has three components or three terms. Okay, three component or three terms, and out of which first term is a DC. 3 is a DC signal. Okay, 3 is a DC signal. It is not AC. So 3 would mean something like this. Its amplitude 3 hai. With time it is constant. So it is a DC signal. Okay, so this is a DC signal. So first term is a DC. Okay. Just a second. First term is a DC. First term is a DC. Okay. First term is a DC. And for DC, you know that it has a DC term has zero frequency. Okay. It has zero frequency. So this is DC term. ये T है और ये 3 है. And what is the frequency of the signal? Frequency is 0. So this is the first term. Okay. What is the second term? Second term is, I'll ask students what is the second term. Okay. Let me ask the students. Roll number 33 is here. 33.
Yes, sir.
33. हाँ बताओ बेटा, what is the second term? It is AC or DC?
AC.
How much is the amplitude?
5
5 or minus 5?
minus 5. Sorry, sir.
Minus 5. Okay. How much is the phase shift?
30 minus
30.
30.
Minus 30. Very good. ठीक है. Second term is AC. Okay. Second term is AC. It is 40 pi t minus 30 degree. Okay. We can also write it down like this. Now see, if we convert this negative sign in the amplitude, we absorb it in the phase, then we will write it down 5 times cos of 40 pi t minus 30 degree plus 180. Okay, plus 180 degree. We are absorbing the minus sign into the phase. Okay, so we can write it down 5 times cos of, let us write it down, we have 2 pi omega t. 2 pi omega t की फॉर्म में अगर हम लिखेंगे, so it is 2 pi
20t
into 20t. 2 pi 20t. अगर हम इसको लिखेंगे 2 pi omega t के फॉर्म में, if we write it down in the form of 2 pi omega t, okay, 2 pi omega t, so it is 2 pi 20t. 2 pi 20t will make it same. And what will be the angle? It will be 150. Okay, so that is one term is gone now. So third term, we have third term. Yes, please ask me, what is your question? कोई पूछना चाहता है?
minus 30 plus 180.
Minus 30 plus 180 कितना होता है? How much is that?
So yes, 150.
That is what I have written, 150. Okay. Third term is, it is 4 times sine of 120 pi 120 pi t. 120 pi t. Okay, this is my third term. We can write it down. इसमें जो amplitude है वो तो है ही positive, so it is 4 times sine of 2 pi, yes, 60t. Okay, 2 pi omega t, if we write it in this form. Okay, now since the signal is in sine form, it is in sine form, we have to convert it in cosine form. So I'll ask students, मैं जिसको पूछूंगा वही जवाब देगा. Suhaib will turn off his mic. Roll number 36 is here. How will we convert it? 36? 36 है यहाँ पे.
Yes, sir.
बताओ बेटा कैसे इसको करेंगे convert into cosine?
So, we will, sir, हम इसको cosine में sir cos sin is equal to cos of theta minus 90 degree.
Very good. Cos of theta minus 90 degree. So we will write down, please turn off your mic. We'll write down 4 times cos of 2 pi 60t minus 90 degree. Okay, that is very good. This is the correct answer. So this is, now you have 3 terms. Okay, so one term you have here, another term we have here, and third term we have frequency equal to 0 and amplitude. Okay, so this is, now we have 3 terms, these 3 terms. If we try to plot them now, so let's first plot the amplitude. Amplitude line spectrum के लिए हमें पहले करना है amplitude spectrum plot. Okay, so we will plot amplitude spectrum. So let us plot amplitude spectrum. This is my amplitude spectrum. Amplitude spectrum. I'll ask Basit, roll number 16. Amplitude spectrum. मैं y-axis को क्या करूँगा mark? Roll number 16. What should I mark on y-axis?
Amplitude.
Yes, what should I mark? Amplitude, very good. Amplitude. And on x-axis, I should mark frequency. Okay, frequency F, which is in hertz. Okay, you can turn off your mic. Now see, I have 3 components. First component is here. Okay, this is first, this is second, and this is third. In the first component, the amplitude is 3. Okay, the amplitude is 3. In the second component, amplitude is 5. Say, for example, you have, this is your 1, this is 2, 3, 4, 5, 6. Okay. In the first component, you have amplitude equal to 3. But what is the frequency? Frequency is 0. Frequency is 0. So 0 pe jayega, 1, 2, and 3. Okay. This is the first component. So you have 3. 3 will be marked at the top. At the top, whatever you mark, whatever number is marked, that will tell you the amplitude of that frequency component. That will tell you the amplitude of that frequency component. Now, the second thing you have, what is the frequency in the second component? So this is 2 pi f. Actually, it is not 2 pi omega t, it is actually 2 pi f. Okay. So I have this signal. It could be a cos of 2 pi f t, 2 pi f t plus phi. या हम इसको ऐसे भी लिख सकते हैं a cos of omega t plus phi. This was the signal. Okay. So what is the frequency in the second component? What is the frequency in the second component? I will ask students, maybe roll number 17 is here. Roll number 17 है यहाँ पे. What is the frequency in second component? What is the frequency beta in second component? Okay, Mumin 45. Mumin is here.
Yes, sir.
What is the frequency in the second component beta?
Second component,
Yes, in the second component, what is the frequency?
the 20.
Very good, it is 20. So at 20, you will have a line. What is the amplitude amount of this component? इसका amplitude कितना है बेटा?
5.
5, very good. So it is 5. So somewhere up to this point, okay? So this is 5. This is the second component. So to mark the third one, I will ask another student. They will help me. Maybe Abrar 54, please turn on your mic. What is the frequency of the third component, beta? 54 is here. Ji. Please remove your. Yes. What is the frequency?
So the frequency is 60 and the amplitude is 4.
Very good. It is 60 and 4. Okay. So 4 is somewhere here. Okay. And 60 is somewhere here. So this looks like this. So you'll mark the number at the top. It is 4. Okay. So this is the amplitude spectrum of the signal. These lines are not needed. These lines are not needed. But these lines are important. Sorry. These lines are important. Okay. Important. So this is the amplitude spectrum of the signal. Okay. Amplitude spectrum. Now we'll try to find out the frequency spectrum. What is the next one? Next one is frequency spectrum. Okay. Sorry, phase spectrum. We'll try to find now phase spectrum. So line spectrum has two parts. One is amplitude spectrum, another is phase spectrum. So we'll try to find out now what is the phase spectrum of the signal. Okay. And I'll ask students, they will help me in drawing the phase spectrum. I'll ask my students to help me to draw the phase spectrum. Okay. So say for example, this is phase now here, and this is frequency F, and I have somewhere this is positive phase, this is negative phase. Okay, negative side of the axis. Similarly, you have marking as frequency equal to 10, then you have 20, you have 30, 40, 50, 60, so on and so forth. Okay, 70. All right. So for component 1, I'll ask students for component DC component, first component or first term of the signal, what is the phase? What is the phase? Okay. So I will ask students, maybe I'll ask Aruja is here. Aruja, roll number 51.
Yes,
Aruja,
sir.
what is the phase?
Yes, sir. So 0 first component में 0 है.
Very good. It is 0. So it will be plotted at 0 because this is 0. Okay. So this is positive and this is negative. ठीक है. Okay. Please turn off. Thank you. I will ask Mehrajuddin the next phase for the phase of the next component. Mehrajuddin, roll number 68.
Yes, sir.
What is the phase for the next component item?
Sir, plus 150.
Very good. It is positive and it is 150. So I will go somewhere here and I will mark it somewhere 150. Okay. So it is 150 degree. 150 degree. Okay. And for third component, I'm going to ask another student who will help me to find out or to plot this. Maybe Ayman is here. Ayman, roll number 78.
Yes, sir.
हाँ बताओ बेटा, what is the phase of the next component?
So minus 90.
कहाँ पे ये plot होगा? 50 पे, 40 पे, 30 पे?
So 60.
60 पे. Very good. It is minus 90. Okay. So this is minus 90 somewhere here. So this is minus 90 degree. Okay. This is how we can plot the phase spectrum and amplitude spectrum. Amplitude spectrum of a signal. Okay. Whatever signal you have. It is not that much difficult, but if we think we can, you would have noted one thing, that we have been given a composite signal y of t equal to 3 times minus 5 cos of something. Then what we have done, we have first decomposed the signal into its components. Okay, that is the essential, or that is the beauty of the frequency domain analysis or Fourier analysis. We actually break down a signal into its frequency components, individual frequency components, then we plot it in terms of amplitude and phase spectrum. Okay, So if you have been, if some signal is given to you, these will be the common steps. That is how you will have to deal them. Okay, that is how you will have to deal them.
In the second term, why are we not using minus 180 degree?
What are you saying? Why of
So in
कहाँ
the
पे?
second term, why are we not using minus 180
You
degree
you
instead of
can use
180?
minus 180 degree also, because it is quite open for that. It is quite open
So
for
the
that.
these
You can
angles
use
differ.
हाँ हाँ, फिर से बताइए.
These angle differ करेगा सर फिर?
फिर आपका बनेगा -180 और फिर बनेगा -30 इसको ऐड हो जाएगा. It will become -210. But that doesn't matter. The amplitude value will be always same. Phase अगर आपका वो होगा, it is not a big deal. ठीक है, आप उसका माइनस भी ले सकते हो. That is also true. That is not a big problem. और कोई सवाल, किसी बच्चे को कोई सवाल होगा तो आप पूछ सकते हैं regarding this line spectrum and phase spectrum. If you have any question, you can ask me. अगर कोई बच्चा पूछना चाहता है, मैंने यहाँ पे भी कहा था, you can either add 180 or you can subtract 180. It is one and the same thing. There is no problem. जो बच्चा प्लस करेगा 180 और कोई बच्चा माइनस करेगा, इसमें कोई असर नहीं पड़ेगा आपके. You will get the same marks as far as your entire method is correct. If you have any question, you can ask me. Otherwise, we'll move to the next topic. Okay, let's move to the next topic then. This takes us to the next topic. Actually, the topic is the same, but the signal is in a different form now. This signal that I have shown here, it is very easy. Okay. Familiar with complex signals. So I'm trying to draw now the amplitude and phase spectrum of certain complex signals. Okay. So the term is complex sinusoids and frequency response. I think I'll take this topic next time. I'll ask students to present their presentations first. Okay, मैं आज आपकी presentations करूँगा.